What is AIRLab? AIRLab is one of the first labs in robotics in Italy. Actually, we have been the second one, and the lab is active since 1973. Here you see some of the first robots that were developed. The Moro on the left is the first mobile robot, fully autonomous mobile robot in Italy. It was holding a computer as big as the place that you see there behind the doors. It's about 2 meters by 1.5 meters, something like that. And on the side, another robot that is came a little bit later. It was one of the first that was developed basing on commercial products like a toy car. What we are doing is putting together AI, robotics, and machine learning in order to have what we may think about as intelligent robots, actually. We perform basic research about autonomous robots, but also applied research with projects that are both funded by the European Union and by companies. We have also some experience in innovation. Some of our PhD students started spin-offs on different things, from hardware, like the one that you see here, that is a kind of a set of electronic hardware intended to make possible to build the electronics of a computer, of a robot in a short time. And this is actually inside one of the robots that are also in the automation lab here, which is the robot from Comau for this kind of things. And other spin-offs born on other technologies. We will talk maybe a little bit later. We teach master and PhD courses, and in the past we had some experience in innovative formation also for secondary schools. We have a lot of interdisciplinary collaborations. As you may imagine, AI is something that is applied nowadays in many fields. And also robotics, if you think that a robot is actually anything that can sense, move, and perform autonomously something, we have that robots can be considered as pervasive in our world nowadays. Even an autonomous car, like the one that you see there, is actually a robot. And then a lot of passion and enjoyment. This presentation is divided in two parts. The first part, in the first part, I will tell you something of the things that I'm doing personally. And in the second part, Professor Matteucci will show you some of the activities that he's doing. And then we have a third part outside, and we go in the actual lab. So first topic is human-robot interaction. Actually, we aim at having a rich interaction based not only on speech, spoken language. Actually, we don't work much with spoken language, but we work a lot with gestures and movement. You can see there some of the robots that we have developed, and you start to see that the robots that we are developing robots. Also, the first ones that we have seen have been developed, not both. So many of the robots that we use are not coming from the market, but are coming from our workshop or something like that. And these robots have some shape and material that are not at all common. The robot that you see here below is a robot that was developed by students to study how to express emotions. And in this case, we have a robot that is trying to detect with very simple sensors whether there is a person. And if there is a person, it can show that is somehow happy. and stay happy until the person is inside. Then there is another obstacle. It takes measurement, try to understand if it is large and high as a person. It is not, and it's becoming sad. So this was one of the first experiments that we did to try to express emotions without speaking, so only with motions. And then we worked on many other things. So we have robots that are expressing emotions. We are working a lot on these kind of things. Robots that are adapting to the state of the person they are interacting with. And we consider this as a step to the situation that we will have in the near future, when we will see many robots that will assist in many sense, not only elderly people, but also ourselves. Nowadays, a lot of robots around in the world are there to provide some service, so they are so-called the service robotics. And actually, millions of robots are entering our homes every Christmas as toys. It's a way of putting robots in the hands of people, regular people, let's say people, not non-expert people, typically children. And this offers new play possibilities because we have toys that are actually able to interact, actually able to present things, propose things, and interact in many ways. This is a different way of playing. And about playing, we have developed and we are developing robo games. So games where autonomous robots can play actually with people. So they need to follow the rules to understand what's happening and possibly make the interaction enjoyable and interesting. In general, we have a look also at the possibility of a market. So they are low-cost robots. So you see many different, very easy implementation. Somehow just recycling things like Roomba and trash bin, something like that. Playability, which is less easy than expected, because we don't expect to develop games or play experiences but by expecting that people is performing something special. We would like that people play, to play naturally, and this is something that requires some funds. This is an old game that we developed. You may see there is a drone here. And this drone is playing a kind of a game where is from time to time is firing like the Jedi trainer in the first Star Wars movie. And when it's firing, the trainee should try to parry by putting the laser sword just in front of the chest. And below, you see on the right the visual of the robot, so what the robot can see, and on the left, the interpretation of the robot. This game was very engaging after some tuning, and was tried also with people at fairs and in situations where actually people after a few seconds felt comfortable with the possibility to play the things. I cannot see. Okay, so let's stop it here. And here we have another game that we have developed more recently, where the robot is Oops, sorry. Back. Where the robot is adapting to the player style. Here, the player has to push the buttons on the towers for at least a given number of seconds, at least 4 seconds for each tower, and the robot can destroy the towers. So, and you see that at the beginning the robot is performing quite dummy actions, but as the player starts to run a little bit faster, the robot, you will see, will make feints and will make something making the player even more running. And so this is because it's trying to adapt to the behavior of the player with the aim not to win, but to make the game engaging and interesting. Then we have a lot of work using robots for disabled people, so to support people with different abilities to face activities or to develop new skills and abilities. We have developed in the past a wheelchair with a shared autonomy. So the idea was to provide a tool that could be used by people that has a problem to manage an electrical wheelchair. And so the wheelchair knows where it is, knows where are the places that the people would like to reach, and check the possibility to reach there, and supporting the people with the abilities that are remaining. We also face problems with people with different cognitive abilities. In this case, we have a robot that has been tried in this situation to interact with a person that has usually relation problems. And despite the fact that the therapist would like to do something special, the person here is actually finding a way to interact to the robot. So is interacting in a new way. And after this experience, the robot that is, she is doing whatever she likes, not what the therapist would like. And at the end, she was able to show to the others what was actually the possibility to play with the robot with the game that she developed. Here is another example of this kind of things. We have developed a lot of robots. In this case, it's a physical problem. And the person in the wheelchair should put a colored ball in the mouth of the robot. And the robot takes the color of the ball. The robot can be autonomous or driven, and this is intended to somehow train the ability of managing the fine movement, both of the chair and the ball, let's say. And in general, we try to also to integrate the play dimension. This comes also from the experience that we made with the EU network LUDI, which was intended to support the people with disabilities with the game experience, so make them playing and improving with the play. And we also have started an initiative, Playboat for All, you see here, playboatforall.polyme.it, that are organizing under different hats the possibility to play and build robots for people with disability, both as passion in action activities or as other ways of performing this kind of activities. The last slide that I will show you on the things that we are doing, that I'm doing actually, are the application of robots in art and entertainment. One of the things that is nice with the robots is that they can be made in many shapes and they interact in many ways. This makes it possible to implement interactive art installations. We are collaborating with some artists to integrate both AI and interaction, say, in some artistic artworks. And we are also trying to start projects on these topics at European level. Then we are developing theatrical robots, and we intend to have robots playing as actors in actually scripted theatrical plays. Here is an example of the first one. The full video is this is the link to the full video, but I will show you just a part. This is a robot that can know where it's a robot that can talk and take the line of the script at the right moment and perform actions. Here is representing a part of Pinocchio with some things closer to Pinocchio, to the real Pinocchio. Actually, the script is very, very close to the original one. We just changed something to put more, let's say, related to robotics. Actually, you see that the shape is quite strange, and the robot includes the ability of mobile robots, of knowing where they are, with the ability of synchronizing with a scripted action. We are improving this situation by implementing improvisation robots, so able to understand what's happening on a scene that is not scripted, but is invented on the fly, and propose actions, so activity, make the action continue on stage, and answer properly to the others, so both other robots or human actors that can be on the scene. The typical improvisation setting is starting from some suggestion from the public and then develops according to the fantasy and the interaction of the persons. So here, this is very challenging, and we are trying to integrate everything, not only because this is an interesting thing for theater, but also because this is a necessary step to have a robot that is really interacting with people. So is really able to face and preview unforeseen situations in a real world, in a setting that is theater, so is a little bit controlled, more controlled than the real world. Now I leave the floor to Professor Matteucci for the rest of the presentation. Okay. Now you should be able to.
Yep. And now you should be able to hear my voice from my microphone instead of Bonarini's one, which I will. Okay, thank you, Andrea, for muting yourself. Okay, so we are two here, and let me also remove my mask so you can also see my face. Just 1 second, and let me switch on my camera. So this is me. This is quite unusual also for my students that are used to see me online, but they rarely are able to see my face during classes. So we are speaking about two aspects of what is called service robotics. So the AIRLab is mainly focused on what is called service robotics, and it is somehow a counterpart of the classic industrial robotics that you could find in an industrial and automation robotics lab like the Merlin. So our research is focused on service robotics, and in particular on two kinds of service robotic. The so-called personal service robotics, where a robot interacts with a human, and you have seen with Professor Bonarini so far several examples and several applications, and professional service robots. So I will mostly discuss our research interest in the professional service robot field. And in particular, I would like to discuss my interest in the professional service robotics, which is robot perception. So if robotics, AI, and machine learning make robot intelligent robot, one of the key aspects to get autonomous robot is robot perception. Indeed, this is what makes the real difference when a robot goes to the real world and has to perform a task. That is, it has to understand the real world. So what does it mean to understand the real world? Well, to understand its position, the object surrounding, the geometry of the environment, and the semantics of the environment, where semantics means the meaning of object and item. Here you see some example from one of the classical scenario. You have an autonomous car moving in the environment, and it is labeling with a different semantic label, which is car, street, vegetation, building, sky, the images that are collected. So robot perception is about making sense of sensors data, not just taking them as they are. A typical technique that we use to do this is deep learning and machine learning. Indeed, some of you might know me because I'm a professor of the robotics course. Robotics is the name for students in computer science, while in the automation engineer is way longer, so is perception, localization, and mapping in mobile robots. Now you understand why I usually call it robotics for short, because the name is longer. Another course that I teach is about deep neural networks and deep learning. Indeed, this is an example on how to use neural network to perform semantic analysis. Semantic is used in many robotics tasks. Another classical task where semantics is used is in agricultural robotics, where the robot has not only to distinguish between soil and plant, but it has to understand which plants are good plants and which are weeds that maybe should be manipulated, which means extracted from the ground to relieve the good plants from the weeds. Here are two applications. One is in the sugar beet field, the bottom left, and the other one is on the detection of broccoli heads for robotic production. Indeed, we have been doing some work in the past, and we are currently doing robotics task on the field. This is one of our main interests. That is to challenge robot perception with the real data, not with simulation or purely mathematical models. We would like to provide the robot with real data and make the robot understand what's surrounding it. On the left, you see a cart which was used to acquire several sensors and build the 3D model of this vineyard. The bottom image is the 3D LiDAR reconstruction of the vineyard, and on the top moving you see the segmentation of the vineyard, where we get information about each single plant and the let's say canopy of each plant to build some health model for the vineyard. This work was done in a previous thesis. Now we are developing a new robot, which is on the right. Students of my robotics course should have recognized the robot as this robot, and the data acquired by this robot has been the subject of this here homeworks. We are building this robot with several cameras, a LiDAR, some odometry system, and RTK GPS. So our goal is to fuse different sensors. Indeed, sorry, there is some audio which I did not remove in the videos. Let me see which one. I think it's this one. Okay, perfect. So here you see another example of fusing on the field the different sensors. This is a European project that we did. This is a collaboration with the automation lab, the Merlin, where they handled the manipulation part, while we worked on the autonomous navigation and perception part. In the center, you see a 3D reconstruction of the bunch, of the plant, with the idea of detecting reasonable places to put those pheromone dispensers with the manipulator. On the top right, you see some activities like mission planning, localization, autonomous navigation, and finally the manipulation activity where the manipulator, which was mounted on a ground robot, was performing a 3D scan of the plant and then deciding where the pheromone dispenser should have been put. Here you see again 3D camera and the LiDAR, which are used to perform the 3D reconstruction. In general, what we do is to collect data from multiple sensors, either if we work on a vineyard or if we develop an autonomous van like on the top that we did with a company here in Italy, or with, let's say, another platform that we have developed, this time again with Merlin, which was used in military application. And we develop the algorithms for multi-sensor data interpretation, either they come from cameras, lasers, sonar, GPS, more recently also from radar. And we do localization indoor and outdoor by fusing the sensor, maybe reconstructing the 3D environment. And once we have a map, we can plan a trajectory upon it. These are the typical research activities that we do. And we do this also, for instance, for autonomous driving. Again, for students attending my robotics class, you know Paolo Cudrano, which is one of your teaching assistants. This is his master's thesis before starting the PhD. You see here the car which controls his central position on the Monza the track. The day he decided to test his algorithm was particularly unlucky, as it was raining. So you see the image, which is seriously corrupted by the rain. But this is the typical condition that your perception system has to deal with. I mean, again, assuming you know where is the center line, doesn't mean that when you will go on the field you will know it, and you have to deal with rain, with possible different lighting condition, and this is exactly what we are interested in. Still in the field of driving and sensor fusion, we are also studying the interaction between humans and vehicles. This is, in a sense, in the intersection between service robots for personal use and service robots for professional use. Indeed, we keep talking about autonomous vehicle and the fact that in the future all vehicles will be autonomous, but so far there is little if nothing about the understanding on what is the human reaction when a car is driving alone and when you are not allowed to take control. This is the level 5 autonomy. But even if you are required to take control, what is the impact in terms of stress? For this, we have developed an instrumented vehicle with several sensors to perceive the environment, but also to track what the user is doing. So in this case, you see on the right the data acquired from the vehicle sensors in terms of surrounding on the top, and in terms of what the user is perceiving. Again, here we are using sensors. We are doing sensor interpretation. The blobs that you observe in the 3D data, as well as the bounding boxes that you see on the images, they've been extracted with deep neural networks. And by doing this, we are able to collect statistical data on the fixation position of the driver. So, for instance, we know how much the driver was paying attention to the street, to the empty space, to the other cars. And the idea is to being able to measure the psychophysical response of the human body and the human physiology with respect to the external stimuli. So basically, when there is a pedestrian, when there is another vehicle, then when we are in a strange situation. And what we are doing these days in Bovisa campus, we are testing the same sensors on the autonomous vehicle that I was showing in the Monza track, to evaluate how is the reaction of a person when it's not allowed to touch the steering wheel, when the car is driving by its own, and whether there are particular configuration or particular control strategies that increase or decrease the stress. Indeed, the key point, or one of the cornerstone of our research, is not just building robots. Indeed, beside the car, but also part of the car has been instrumented by us. Beside building the robot, our interest and research interest is also in benchmarking and evaluating autonomy. We have been partner in the most important new projects and robotics competition for the benchmarking of autonomous robots, both at the level of a component, for instance, mapping, SLAM, perception, but also at the level of full systems like autonomous serving in a restaurant, or being able to deal with people in a crowded environment. Indeed, these are just a few of the names of the project where we have designed benchmarking algorithm for autonomous robots. Benchmarking autonomy is a complex task. I mean, just defining autonomy is complex per se. So beside defining what autonomy is, then you have to define a tool to assess whether a robot is autonomous or not, whether a robot is more autonomous than another, or under which condition a robot is autonomous. So you see here a clear example to what does it mean to do perception in the real world. This is an image we collected while moving autonomously with the robot on the right in the Bovisa campus, Durando. It was close to, I think, 6 or 7, and you see the reflex of the sunset. So we are facing east, the sunset is on west, but we have this nice glassy wall which perfectly reflects the sun in the middle of the camera. So you see that a robust perception, robust AI has to deal with the unpredictable situation. And I mean, students that are studying with me, either deep learning and robotics, or with me and Professor Bonarini, they know how the core of our courses is uncertainty and dealing with uncertainties. So in everyday robotics tasks. So I would like to stop here, and I mean, we can either take some question if you have, or we can try to do this lab tour.
Real tour.
Yes, real tour of the lab. In other situations, instead of having the slides shown remotely, what we would have done is talking in front of robots, just having you in the lab and giving you a presentation in front of the robot. But I mean, it is more than a year that this is not possible. Exactly 2 weeks after the inauguration of the lab. So we inaugurated the lab and then we closed because the shutdown. So basically, no one has visited yet the lab in a physical way after the inauguration. Okay.
Yes, actually, the lab is, as you may know, is one of the three labs of the Department of Electronics, Information and Bioengineering that have decided to stay together in this big place at Building 7. And we are sharing it with Merlin and AIRLab, that is the lab for bioengineering. We are sharing the space. So I will try to move with the camera and show you the things. And in the meanwhile, if you have questions, you want to.
I'm monitoring from my side.
I don't know what you can see. Okay, there's a question maybe. Let's see before moving the question.
Yes, if it's okay, I'll read it. So on the registration, everybody can hear the question, if that's okay.
Would you like now or later?
Maybe after the tour.
After the tour. So we will take the tour and then we go back in this room and we will take the questions. So you may see here, I hope you can see.
Can you see?
Yes. So I show this. Okay. So this is the workshop where actually things can be built. This is the work. Oh, sorry, it's always the wrong one. Sorry. There's a workshop that allows to make some mechanical stuff, electronic stuff, and some materials that are there. Okay, that's just to show the workshop. Then let's go upstairs. There's a short step, and here is the lab. You may see there is the Merlin area. This is a shared area. And then we have the AIRLab area here. And we have here the AIRLab area. And anyway. Here you see some of the robots that have been developed from the course of this year. It's the 10th year that I'm taking together with the professor of the design department, a course of robotics and design, where engineers of all kinds are developing robots together with people from design, together with designers. So you may see some the results of some interaction between the two. Here we have robots. This year were robots that were intended to invite people in different kind of exhibition. Here we have the Museum of Campari, and so this robot is performing activities to invite people to the Museum of Campari. Here we have Banksy. Here we have Magistretti, is a designer. We have a trash bin for the recycling lab, the recycling museum at the Museum of Science and Technology of Milan. This is Robocchio, as the robot that you have seen performing before. This is actually a basis that started as a basis for playing soccer. We had a soccer team for the World Championship. And it is a basis that is more or less as many of our bases is made by omnidirectional wheels, so we can have an omnidirectional movement by composing the speed of the three wheels because the wheels are made of tumbles that can work in one direction and can just slide in the opposite direction. The object that you see here is actually a stand that is coming closer to the people entering the lab and asking to put a coat there. If you put the coat, it is happy. If you don't put, it just move away. You can find this on the AIRLab YouTube channel. Here,
okay. I will try to present this. So this is a robot that we are building these days for agricultural application, and we have a four-wheel drive robot. This is one of the few commercial bases that we have. This is not been built for the bottom part by us, but we are setting it up with the sensors. You see downwarding cameras for understanding the presence of weeds. You have some other cameras here for 3D reconstruction and position tracking. You see a LiDAR sensor here for 3D reconstruction. So actually this is currently a master thesis of a student from automation that is working on this these days.
you can show maybe the cameras. So
Okay.
we have a system. This area is covered by a system that is made of 12 cameras, able to detect the precise position altogether of markers that can be on top of the robots, so that we can check the quality of the self-localization algorithm that we developed. This is a marker, the one that you see maybe here. Yeah.
Okay, good.
This is a marker that can be seen by these cameras that are infrared cameras, and so they can put together the data with the system and detect the thing.
This is this yellow robot is another robot that we are working on. It is a commercial robot, and the company has asked us to improve their localization, mapping, and navigation algorithm. So this is another work that we are doing together with the company. There is another student, actually, I think it's from your same association, if I'm right, and he's working on this robot to improve the localization system.
Here, just a quick look to the intelligent 3D printer that we are developing. This is intended for dummy people, so the people that are not able to 3D print anything, and so you can just give a file and it will take care of whatever happens. Here, yeah, here you see there some of the things that we are animating together with an artist. So these are artworks. You may see whatever this means. What you see here is actually a game that is being developed by a student that is actually from bioengineering, and it's a game based on. You see that you have to press the proper sensor. They are capacitive sensors with the rhythm that is suggested by the video that is there. This is intended as a kind of exercise, both for reflex and physical exercise, depending on the speed. Now it's going slow, but if you go fast, it's impressive. Another strange thing that you see here is this. This is a system that is intended to make disabled people able to play this Charleston without being able to use the foot. So it's playing the Charleston together with the usual drum, by putting the position, the stick in a given position. When you put the stick in that position, the Charleston is moving. This is one of the robots that are being developed for the Passion in Action this semester. We have this Playbot for All activities in collaboration in the semester with an association that is called Hackability, that is aimed at developing tools, technological tools for people with disabilities.
Yes, here we have a Supermark cart. Actually, it is a robot. Indeed, if you see on the bottom, you see the wheels and the computer and a leader. This is one of the benchmark we have developed as part of a project. The water is there because of the weight, it's not because we are thirsty, because we would like to develop a system to benchmark the capability of a humanoid robot to drive a cart. This will be tested in September in Bologna. There will be an international competition for robots, and we would like to have a humanoid robot pushing this cart around a small circuit. We will have some visiting colleagues from UK here in the lab the next month to prepare a robot. In this case, it's not a humanoid one. It's a robot with a manipulator to push this cart along the entire trail.
And here you can see from the top here some of the robots that have been built in the past in the robotics and design course. Every year we have different topics. You cannot see much because they are far away, but there are robots that were designed to play and to dance and represent a special type of music. We have there funky. We have there we have let's say disco there, and electronic music, and then Daft Punk, and then here is grunge. This is playing a grunge, and then at the end, the head is detaching to the body when you finish, because you have to have this kind of behaviors and this kind of things.
So we take a look from one corner so they have a sensation on how big is the lab. Give them an idea. So we are in a corner, so this is more or less the lab. Yeah, this should be okay. Perfect. This is the lab. In the middle, you see an open area, which we modify almost every 2 months, more or less, to test a robot, to do new projects, to do new theses. This is the cart that I was presenting during the presentation with the sensor. And this metal frame is the part that will be used for the shopping cart pulley that I was mentioning before.
Just finish the tour by going this way. Here we have a robot that is intending to match the heartbeat of the person. So you put the hands inside the robot, and the robot starts breathing with the rhythm of your heartbeat, and then diminishing the rate of breathing tend to make the things more, to make you more relaxed. And with this, we could make almost sleeping a lot of kids at Maker Fair a couple of years ago that were coming very excited and making their mothers quite happy to have them come by. As you can see, we have many kind of robots around, including this is from one of the projects, industrial project that we had with a company that was producing this, which is the inspiration for becoming robotics people for many people. So this is a very old robot. This is a famous robot toy. Maybe the first robot toy that we had in Italy many years ago. I was a kid, so it's 40 years ago, 40, 50 years ago. So we are going back to the room for questions. So please, if you like to ask a question. Yeah.
Okay, thank you for the tour. That was very interesting.
Maybe a little bit too moving, but
so yeah, we have a lot of questions. I received questions privately too. So I will just be reading them.
Okay.
So the first question we have is a public question and is from Lars. And I think it's very interesting because I thought the same thing while speaking about autonomous vehicles. How is the correlation between the AI and robotic lab and MOVE research group? Lars says that for autonomous vehicle, it seems like there's an overlap of interest between the two labs. And he thinks it's a fair assumption that the group mainly works with perception and location. Meanwhile, the MOVE lab mainly focuses on information for control.
Okay, can you hear me?
Yes.
Yeah, okay, good. Because, yes, indeed, well, there are different labs at Politecnico di Milano working on autonomous vehicle. There is a group in the mechanical department. They mostly work on the mechanical part and the mechanization of the vehicle. There is MOVE clearly, and we as well. The different groups, they specialized in their main research interests. So personally, although I mean, I have some control background as well, but my main interest is perception. So we are interested in providing the information that is required for driving. Then the control part is not my research activity. So basically, I'm more interested in all the part which, given the sensor data, provides the interpretation which tells where am I to the control algorithm that then has to deal with all the stability issues, optimality issues, non-harmonic constraint of controlling an Ackermann steering vehicle, possibly at a high speed, which is mostly in the activity of Merlin, for instance. In our case, I'm more interested in general techniques for making sense of sensors and data. And this is probably one of the differences between the activities of the two labs. And depending on which activity you would like to, let's say, spend your time at work, you should look at the different labs, for instance, including the mechanical part.
Do you feel that your work is helpful to the other lab?
Well, in principle, yes, for sure. In a sense that if you, well, in some cases, I can tell you, yes, the machine, the car that is at the mechanical department, which is autonomous, the blue one that we tested in Monza, has the perception done by us. And it is the result of a joint project funded by the Lombardy region. So Regione Lombardia has founded a few years ago a project where several groups from AI, automation, the electrical group, the mechanical part, they have all worked around the same vehicle. And for that vehicle, the perception part has been developed mostly by Simone Mentasti, another person who is known to the student of my robotics class.
Okay, thank you. Now we have a few questions about the master's degree in automation engineering and about the master thesis. So I'll just try to sum it up in one question. Which are the exams that are recommended in order to possibly work in the service robotic? And is there a way to write a thesis in the lab? How contacting the professors, or how a student can write a thesis with your lab?
Okay, so let's say that the courses, so unfortunately we don't have a track, interdisciplinary track on robotics. Robotics is one of the most interdisciplinary topics that are around, and in principle, a lot of the courses that have been that are proposed both in the computer science track and in the automation track would be useful. So, of course, there are courses about perception, vision, and machine learning, deep learning. Professor Matteucci is also teaching me deep learning. And the aspects for the things that I'm doing are covered by the design course, the course of robotics and design. But it's often quite difficult to match them with the constraints that are given by the study plan.
This is true for the automation study plan. Usually, all the students from computer science can take them all. So the AI part, the perception part, the deep learning part, they are part of the study program of computer science.
Actually, we have a track in robotics in the computer science master track, and we have also a new full track in AI and machine learning, always at the master track in computer science.
This does not mean that we don't take students from automation. Actually, we have also students from automation during the thesis. Right now, I think that I have at least 3 or 4 students from automation doing the thesis for us.
One of the ones that are doing the theater robot able to improvise is from automation. His passion was to play actually with as an actor. So it's very much interested in this kind of things.
So usually, what I suggest is, but to take courses. Unfortunately, you cannot, because the study program in automation engineering normally doesn't have such a flexibility, but for sure you can take the perception, localization, and mapping course, and you can probably add some machine learning, deep learning course as a like personalized study program. You can add, I think, computer vision and the multi-agent system to your program. This is normally done. Taking all the courses that we teach, it's usually not easy for a student unless you change. I mean, that's a totally different story. But this doesn't mean that you cannot do a thesis with us. Usually, I suggest to ask directly to the professor of your course. So if you want to do a thesis with Bonarini, you just get in contact with Bonarini. If you want to do a thesis with me, you have to get in contact with me. I can give you some suggestions. So first of all, don't do it too early. So, I mean, if you are in your first year of master, I mean, too early. If you are in the first semester of your second year of master, too early. So don't, but this is not true for me or Bonarini. This is true for any professor. Don't start working on thesis before you have like 15, 20 credits remaining. So that the 15 is better, 10 even better. Because usually the thesis requires a lot of time. You see, our thesis are very practical. So you have to spend time understanding the tools. Sometimes you didn't take all the courses with us, so you have to fill up a little bit of background. And having also to attend like 35 credits usually is very tough. So my suggestion, but this is a general suggestion for students approaching a thesis, is to wait 15 credits, 10 credits to the end, and then go to the professor, introduce yourself. Maybe that at that time the professor has many proposals, sometimes has a few proposals, but at least all the professors that I need, they always have thesis available. Sometimes they have peaks. So, for instance, this winter I got like 30, 40 requests for thesis, and I cannot take so many students, and the same is for Professor Bonarini as well. But this is not a good reason to book your seat for the thesis too early with respect to your normal study program. It is better to do the most of the exam and then take time to do the thesis, because the thesis takes time. I mean, I think that the thesis is a very important learning experience. It's not just a gate for graduation. I mean, it's the place where you will learn something completely new. And I mean, I think at least this is my vision of the thesis.
Yes, yes, of course. And in general, there are many exams when the program is done, this goes for a long time. So I strongly suggest to have 2, 3 exams left. And actually, in my faculty page, I have general topics, but every time there is a single aspect to bring on a specific topic that can be decided at a given moment. Next semester will be different.
Yes, and the last but not least, do the thesis about something you're passionate about. I mean, don't do a thesis because then I will do this job, or because no, do something that really excites you, something that you think you will shine for some reason. And I think that because a thesis is long, is several months, or several is more than 9 sometimes. So if you do something that you don't like, it will never end. So it's not like an exam that once you've done the exam, forget about it. I will never touch, I don't know, control theory anymore in my life. I don't know, I'm just making this up. It's a thesis, you have to take it till the end.
One last thing about the master thesis. A question from Elena. Can a single thesis require collaboration with more than one lab at Polimi, such as your lab, Move, Merlin Lab, and so on?
This may happen, so this depends on the topics and on the agreement among the professors. So if the professors agree to work on topics, they will work together. So in many situations we have multiple professors.
So in some of the projects that I've shown, like the one on the big truck or the manipulator in the vineyard, it was a thesis together with Merlin, for instance. another thesis that we co-advised was about mapping in the agriculture field. It really depends on the thesis and on the project available. So, for instance, the one on the autonomous one that we did with the company, it was together with Merlin as well. So I think that it is possible to have this kind of collaboration. We had the project together with Merlin. We are now, for instance, we are looking at an inspection system for glass and bottles, where the bottles need to pick it up and inspect it by a vision system. And obviously, Merlin is handling the manipulation part, and I will deal with the perception part. So yes, it is possible. It comes from time to time, and it varies every 6 months, more or less.
Okay, I think we're done with the thesis questions. Okay, we have an interesting question from Giulio. He asks, are you also working with theme parks? I'm thinking, for example, about Disneyland and their animatronics, and he believes they're fairly advanced.
Yes, there is a really advanced lab in Zurich performing robotics for, in principle, with the aim of having robots in the parks, but also for this. The robot, for instance, able to match a hole 25 meters below, but by jumping from a building. And this is intended to be the one that will be covered by a Spider-Man image or something like that in the real world. They are very advanced. They're very advanced. We don't collaborate with theme parks because they require actually products. And we are performing, we are studying, let's say, a prototype. We don't come to a product. Usually we come to prototypes. So the closest thing is the collaboration with artists that are doing some installations, and we are usually work in fairs or shops or things like that. Actually, theme parks is something really demanding. It's needed to have a structure that is a structure of a company, not a structure of a university.
Okay, thank you. When making a robot, how is the problem of unpredictability of human behavior managed?
This is a big deal, really big deal. You know that one of the things is to try to have models either learned or
I'm sorry,
AI.
I have to interrupt and ask if one of the two microphones can be muted, please. Thank you.
Okay, thank you. So I was saying one possibility is to have models to interact with people, which means that we assume that people is more or less behaving in ways that are predictable, or at least we can understand the way people are acting. I'm working now. I have a PhD students and a couple of students working on activity recognition, for instance, in order to detect from image and the skeleton that you can detect, detect from the image what people is doing. But the certainty about this is always something related to the quality of the image and the quality of the movement, the quality of the model. So it's never 100%. It's always some percentage. And so you have to manage this kind of thing. And in improvisation robotics, in the improvisation application that I was mentioning before, this will be very interesting because this depends on how the robot can understand what happens on the scene. And this is something that is also difficult for human actors improvising. But the human improvisers are able to manage the situation. So we will have the robot that will understand something, maybe not what was intended by the human actor, and then the human actor will have to manage, and they will have collaborate online and in real time. This is another big issue to perform this kind of things. We are trying to use dedicated hardware for AI. We have many things that are done by deep learning, and we are using GPUs, which are fortunately also quite low cost at this time to perform this kind of analysis. And then we have to manage models that can check the situation, try to understand the best, and try to act. Of course, in many situations, this is not possible. So it's not possible to be sure 100%. And so the robot should be able to do something that is reasonable. In some cases, the something is just to stop and ask, or stop and ask for support. In some cases, is to try actions and see what happens. Let's say that with respect to a typical control situation, we have the change of set point every, let's say, 100 milliseconds. So you may have the intention to do something, start to do something, then sensors tell you that something is happening, and you have to change the set point. So this is something that is continuously going on, and you continuously have to adapt to the situation.
But is the fact that we're not 100% sure how the robot will react to unpredicted human behavior that a lot of prototypes just remain prototypes, they're not sold or developed more?
No, this is one of the aim of the benchmarking activities. So all these robots are competing in these benchmarking trials. And again, you will never be sure that the robot is performing 100% correctly, but you will be able to guarantee somehow with a benchmark, with something that is, in principle, should become similar to what we are doing with cars or washing machines or this kind of things, in order to make sure with this given degree that the robot is actually performing something correct. But we cannot really expect to have something 100% working. And unfortunately, at the present, most of the also commercial robots are not working at all in a reliable way. Or they have a very poor performance, or they are sold with magic words, but then in practice, we still have a lot of problems, mostly related to perception, mostly related to try to understand what is actually happening, more than in reaction. Because if we have a good world model, a good model of the situation, then we know what to do. If I know what is the situation, I know what to do, and I may have limitations in performance because maybe the actuators are not perfect. There are not so many manipulators around able to do the things that would be useful for an elderly at home, for instance. But the main problem is still to understand what's happening there. So still to build a good model of the situation. And it is not a question of having a prototype, it's a question of working. So it's a question of research. Still question of research.
Yeah, if I can if I can follow up on this, if you see what happened in the last 10 years with the AI and deep learning, is that we moved from a lot of prototype to product because we had this disruptive step that things started working as they should. And the way this happened was by the collection of data, so that to map all possible situations that the AI system would have possibly faced. This is purely in principle. If you have played a little bit with the chatbot, you know that you can trick the chatbot very easily. And this is even if the chatbot is a product, you can trick it because it goes in the unpredictability of the environment. So I think that from a research perspective, on the one end, how to reduce the unpredictability of the environment from a system, from a robot, is what I'm interested the most, or how to make the perception deal with these unpredictability. Then you could have always a situation that will make a system fail. Probably the most famous example, well, the most famous example dates back to the 70s, which is an expert system to diagnose skin disease. It was given with the information of a rusty car, and he provided a disease of a very specific skin disease, but actually the data were coming from a rusty car. But how the designer would have ever thought that someone would have tested the skin disease expert system with the data of a rusty car? So I mean, dealing with this unpredictability is definitely an issue, and well, we have to sort it. Indeed, if you think also, for example, of the autonomous car, the 5 level of the let's say autonomy, they are characterized by the fact that the vehicle has to deal with the total unpredictability. Indeed, the difference between level 4 and level 5 is exactly this. You have specific settings which are instrumented to be as predictable as possible, where the car is allowed to drive safely alone, while in level 5, this doesn't matter. It means that you have solved all the unpredictability issues. Indeed, some of the examples that are tested for level 4 are like a parking lot where you have a controlled environment, or the highway, which is much more structured than a urban scenario. So the more difficult one is not the track, is not the highway, is a urban city. Indeed, I mean, you can imagine how difficult it could be to drive in a packed traffic urban scenario where you have the coexistence of humans and autonomous vehicle. Indeed, if you read some of the blogs of Rodney Brooks, which is a quite famous roboticist, he is clearly stating that autonomous vehicle will start working as soon as you remove the humans from the street. So a pre-requirement is to prevent people to drive before you can actually have autonomous car because of their unpredictability. So yes, you're right. It's definitely a hot topic.
Let me just add 2 words to say that the things that companies have in their hands for AI are more or less the same things that everybody has in their hands, because they need the participation of a lot of people to make such a huge amount of data sets. And this is done by research. And so the difference between the prototype that we can make or the prototype that can make companies is the way we work on that. So how much we work on the data sets, but we are starting on the very same basis, and this is something that is a strong possibility also for for us.
Lars asks if you could repeat the name of the blog. Oh, I think you're typing it.
Yes.
Okay. Okay, and since I don't see any other questions, I would like to ask one last question, just out of curiosity. If you were able to sell one of your latest projects, how much would it be?
So this depends on the project. So the ones that I'm developing for disabled people actually are intended to be very cheap, because they have a market. In principle, they have a market that cannot afford to spend more than a few $100. So it's something like 200-300 euros or something like that. So they should be designed as simple as possible. Then, of course, this depends on the market. So possibly the agricultural robots can be sold for 50,000 or something like that. So this depends on the robot.
Yes, I was exactly going to say something like that. So the price is connected to another statement you were making like 5 minutes ago, which is about the value proposition and how the product will match the market. So I've done a project with students from ASP, Alta Scuola Politecnica, on was more a sensing and AI part to adapt the spraying of an intelligent boom to the status of the plants and the salad in a greenhouse. It was very nice project. They did also the experiment. They were here in the lab almost legally during the lockdown, doing experiment with water and spraying water everywhere. Bonarini knows about this, being the person
on the market.
Yes, on the market, exactly. At the end, the idea didn't make a company, but we were contacted by a company, and they were interested in investing in making this product. Indeed, we filed a funding proposal to move from the prototype to a product, and this step to make from the student prototype to the product was something 150,000 euros. So this gives you an idea of what is the cost for moving to a prototype to a product, and then they planned to spend as much to push from that product to the market. So unfortunately, we didn't get the funding in this case. We are still looking for the funding, but it really depends on the field. An agricultural machine can cost easily, like a tractor, 100,000 euros. So if you do something that adds to that, can be 10,000 euros, 50,000 euros with no problem. It's within the cost. But for disabled people, you cannot count on that much. So I don't know whether I answered your question.
Actually, we have some of our robots developed for disabled people that are on the field. One in particular since 4 years, and they paid just for material, and they were able to raise the funding by playing a soccer game, the art soccer game, and collecting enough money to pay the material and the time that we spend to fix it. But it's working since more than 4 years now. So I'm very proud of this. Actually, this was a robot that won an international prize. It was a very well-designed product, but it's in operation since 4 years, which is not typical for even for market products.
Is there a website of this product or like a link or something we
Yes.
can send it in the chat?
Yes. You can find so there is the link of the lab, which is airlab.dave.polyme.it, and a link for Robot for all .polyme.it. This is a link where I'm collecting the things about disabled people and the things that we are developing for disabled people. And okay, so you can find something there. And then there are papers, published papers with a description of the things. So if you look at my Google page, you can find the papers.
Okay, well, thank you very much. I don't see any other questions, so I would say this is the end of this event. And I would like to thank you, both of you, very much for participating, and also all the people, the students that participated and were interested in today's event.
Okay, thank you. Thank you to you. It's a very nice initiative, and it's very, very interesting. I was worrying about some times ago, some students thought about having a student branch of IEEE for robotics. Are you thinking something like that or not?
I'm sorry?
Thought about. So some students in the past were thinking about opening a branch, a student branch of the IEEE, which is the main association for engineers, about robotics here at Polimi, as it is in many universities. Maybe you can think about this and have
Yes,
this opportunity. It's also a way to get funding by IEEE.
Yeah, we can think about it. For sure, we will talk about it with the board of the association. I don't know if Giulio's still listening, but he might be very interested in this.
Okay. Anyway,
Yes, I'm very.
if you are interested, we can talk. I can address you to the people in the department that are following this kind of things. And it would be something nice because it's an official international recognizing thing, and it's very close to your interest.
Yes, thank you. If you can give me a link or an email,
yeah.
I will try to find out.
You.
Ok, magari passiamo in italiano, diciamo.
Se siamo rimasti solo italiani.
Adesso direi di salutare tutti, poi quando rimaniamo tra di noi vorremmo parlarvi di un paio di cose. Quindi ringrazio ancora tutti, thank you everybody, and I'll see you at next event of AIA, hopefully.
Ma intanto grazie ancora per essere stati qui stasera. Sia un peccato che non eravamo tantissimi stasera, però purtroppo deve essere la sessione che c'è un po'.
Poi c'è il ponte, c'è la sessione, c'è un sacco di cose che sono venerdì, c'è un sacco di cose che sono contro. Comunque c'è la registrazione, sono sicuro che la gente guarderà anche la registrazione.
Sì, infatti abbiamo avuto molte richieste di registrare, di inviare registrazioni, quindi forse sarà anche per quello.
Giulio, hai qualche problema di connessione, mi sa, perché vediamo un triangolino sulla tua figura.
Ah,
non ti
forse
vediamo.
perché stanno al browser. Oh, 250 mega, dovrebbe...
Ok, adesso ci sei.
Adesso ci sei.
Bello sfondo, apprezzo.
Peccato non essere in presenza, che si potrebbero fare delle cose.
Purtroppo siamo nati anche noi come associazione nel pieno della pandemia, quindi
è così,
ancora non siamo riusciti a organizzare qualcosa di No, beh, in realtà è stata organizzata una visita a un'azienda in presenza, quindi quello è stato il primo evento.
In presenza.
Esatto, sì. Scusate, stiamo un po' temporeggiando finché rimaniamo in pochi, così riusciamo ad avere.
Vabbè, altrimenti possiamo anche già iniziare, tanto facciamo uno spot.